All right, we're live. So I guess we can do a bit of self introduction here, uh, so that our audience can know who we are and what we're looking to do in this show. So uh, I'm Jason, and I have here Kai, who's learning to program, and the example we're going off of is this website. So we'll be talking about React and a little bit about each of us. So I'll go ahead for a little bit and then I'll hand it to Kai. So yeah, my name is Jason. I work as an engineer, and we sort of known each other for a couple of years, and we're in doing different career paths, but in uh, in my life, I'm currently working as an engineer at Amazon. I do some like web development, but mostly I do like C++ programming. And previously, I was working in a self-driving company called AutoX. And before that, I was at Apple working as a software engineer. And before that, I was in school. I went to the University of Waterloo, graduated computer science degree, and it was a long time ago. So let's just leave it at that. Why don't you introduce yourself a bit, Kai? Yes, let's hope it goes well. Okay. So what Kai has done so far is set up his machine in Ubuntu. Uh, I guess we can't show it to you because he's not broadcasting. But what I've done is I've just opened up the project myself. Uh, and so what Kai has essentially is this folder here. Um, and you can also get this folder as well. If you want to look at it, you can get it from this website here, DeepWorks Co. example stack. So I assume you have a bit of experience. I guess we'll just start straight from scratch. So here's the website. Let me just open up a new project here. We'll pretend, I have no idea what I'm doing. I'm just looking at this from brand new perspective here. So I'll open. Yeah. So typically we do development in the terminal here. Terminal is like your go-to friend. I like to make a folder called workspace, and we'll use this as the place to clone this project. So I have a tool called git, and we'll use git clone to clone into this. So now there's a folder called example stack, and everything in here is right here. So we'll just follow this tutorial along a little bit. So now we have, I recommend you downloading Webstorm. It's a cool project tool that you can use. So Webstorm, right, just download, and I'll leave you to figure out how to install that. It's pretty easy. So just click download here. But once you have a Webstorm, I have another project open. Let me just create another one. So what I do is you can type pwd for the current directory, and you can go there directly. Kai, you can see my screen, right? Kai? Okay, right. I mean, you're seeing my screen, right? Okay. So here we open it up. Let me go ahead and close the old project. So this is literally what you will see brand spanking new, right? And first of the command says you should do yarn install here. So we're going to run yarn install. Basically, there's a dependency management tool called Yarn. And it is Yarn is the alternative tool to sort of NPM. NPM is the canonical tool that comes default with Node.js if you're doing Node.js development. I won't cover Yarn too quickly, but Yarn is the faster equivalent of that because it's able to do things in parallel. So you have a bunch of dependencies. You'll notice, like in this folder, there's now a new folder, right? Because the last time I did ls, we did not have this node module folder. And what that is that's where all of the libraries are pulled in. So if we did ls and look at what's in the modules, these are all of the things that this full stack requires, which is a lot of things, right? And you don't want to manage that by hand. So this tool takes a look at that at the package JSON here, and it manages and resolves the dependency for you. So if you look at the package JSON, the thing to look at here is there's two sections. There's one called the dev dependencies, and this is all for development. Then for the actual dependencies, you have packages here, API, and then web. And because this is a full stack development project, there's the part that runs on your web browser, and there's the part that runs on the server. The part that runs on the browser is called web, and you can see the dependency is on its own package.json. So all of these dependencies are here, and all of the development dependencies are here. Any questions, Kai? Okay. Which is, okay, got it. Yeah, so Yarn versus NPM, I'm not going to go into the whole debate about it, but Yarn is just a sort of, to me, it's a better, faster tool than NPM, but you can use either one for this project. So a dependency is a requirement for a library, right? So for example, if I was to give an example, to build a house, right? what do you need to build a house? Well, you need lumber, you need windows, you need tiles, bathroom sinks and kitchen countertops. All of these things are items, but there's a hierarchical order. And in a house, you probably want, okay, I want rooms. Okay, what rooms do you want? I want a bathroom, I want a garage, I want a kitchen, I want a bedroom. And so for each of these, like a kitchen would resolve to different things. All kitchen needs to have dependency for a counter, a sink, cabinet, right? So these are dependencies. Does that sort of make sense? So yes. Yes. So if we look at pictures of what this might look like of a dependency graph, it's just like you have a tree, basically. A tree is basically, directed arrow graph, right? Where there is no circle back. So these are dependencies, whereas this is not a this may be a dependency, but these backwards links are handled by your dependency resolver. So that's a dependency. In this package, we have a file that represents all of these dependencies. And so it's listed here in the dependency graph. I don't want to get too detailed into how this works, but everything that needs to work is in here, and everything that is all the dependencies for the back end and the front end are in its own folder. So because this is a web project, we have a back end and a front end. The front end is in the web folder, back end is in the API folder. And in the web folder, there's also a package.json. It has all the dependencies listed in here in the dependency section. And then for just development purposes, there's dev dependencies. Does that make sense? So that's what this command is doing, yarn install. Yarn install looked at all those files and made download requests online and fetched all of these dependencies and put them in the node modules folder. Okay. So we ran the first command, and the next command we need to do is create the local database. So for example, here we have createDB, which by itself does nothing. It's a Postgres tool to create a database. So, oh yeah, by the way, this part you have to install yourself. It's a little different depending on the platform you're on. Like Mac installation instructions are different than Windows, than Ubuntu, Linux. So I'll let you sort of figure out that part yourself. So you create the database, my database. Of course, I've already created it. Let's just pretend I didn't create it. By the way, if you've already created it, you can drop it. Drop it is a destructive function. It destroys it, basically. So you don't really want to do this. If you want to inspect what is inside it, you can use PSQL and take a look. And if you want to look at all the tables that it has, here's all the tables. But I'm getting into the weeds here. there's a whole suite of database management tools I don't really want to get into right now. So we'll just pretend I didn't have this, right? So I'm going to drop DB. Boom, it's gone. So now I've created it. And if I go into it and look at the tables, there are nothing, no relations. So \DT just says display tables. And you can like search up these commands like PSQL commands. So next up, we will want to go to the API folder and start the development. By the way, I'm using the terminal here. There's also a terminal in Webstorm. Just click here, and there it is. So, in fact, you can, you don't even need this. Full screen this. And here it is. You can have multiple terminals, and you can split them vertically. Right. So what I'm going to do is now go to the package folder, and you'll see there's two things. It's just, there's the API and the web part here. So go to the API side. You'll see the same thing as here. And we'll go yarn watch. So what this does is it runs the script that is in here called the watch script. So you can have any script you want. You can say like, yarn foobar, and you can tell it to run whatever you want. And basically you can copy paste. It's the equivalent of copying pasting this command with yarn. It's the equivalent of copying pasting this command and typing yarn run. So if I was to copy paste this, right, it's the exact same. So these are just shortcuts. So you see like the output is the same. API, packages, API. So you'll see like Webstorm has this part where it tells you like where you are at any file, right? Yeah. So what this command, just quickly breaking it down, is it's running tsnd. And tsnd, if we look at what that does, yarn run tsnd. It's just the TypeScript node development tool, right? So it's the same as running that. So we're working in the TypeScript package here. And it's basically saying, dash respawn is if you get killed, try to restart your program. I won't go into too much detail on all of these because I think it's not relevant right now, but just know the last part says to look in the src folder, source folder, and look at the index file to run this file. And all this file is, it is just the server that sets everything up and lets it run, right? Yeah, so here, if you just look, there's a bunch of like imports saying this file depends on blah, 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 blah. Right, and all of these are, the convention is you have some library files that are listed on the top, and then you have your own local files on the bottom here. Like for example, if you hold Command or Control, you can click through to some of these files, right? So this is like the index file I just clicked through. And basically there says, okay, you know, we have this construction, this thing basically that says, if you start it up, the constructor says, you know, if I'm constructed, here's what I'll do. And then, you know, rule of thumb says, okay, first thing you do is tell my boss, you know, that I was constructed. So this is object-oriented programming. You have to understand a little bit about object-oriented programming, right? The notion here is that like this is a particular instance of a server, and it just customizes what this instance does. So this just, the super just calls the super function for whatever a constructor in here is. And then it's running this init, which is this part here. It's saying, okay, init is basically set up the database, set up the authentication part, set up Apollo, which is a middleware, and then set up controllers. You don't need to know all of these too much detail. We'll look at them in some later episodes. And lastly, you know, this object is constructed, and the first command is to say, okay, we will start, right? We'll run start. And that's all there is. I won't go into too much detail, but that's what this command is running. And similarly, that's what worker is running. Similarly, you know, that's what all of these different commands are running. So these are all DB. I've annotated it so that they're all database related. Like for example, if you wanted to run the migration, create a new one. So migrations are in this folder. And migration just tells you sort of what tables to create, right? So if we look at our Postgres table, we'll connect to it by saying PSQL my database, and we'll look at DT. There's already a table for job and already a table for user, right? This is just like a file cabinet. You can think of like job as a file cabinet and user as a file cabinet, right? And actually there, you know, in Webstorm, there's a plugin called database. So it might be easier to look at that. Let's set it up. Do you have this? Okay, so in order to get this, you have to go to your preferences, Webstorm preferences, and open up plugins. And in your plugin, you can search for database. And so this is just the database plugin. Here, database and tools SQL. One of these is free and one of these is maintained by JetBrains. So once you have I'll set up mine, and you can just take a look. You can figure out and set it up later. Yeah. So the setup for this sort of goes like, you know, there's a window here. Here's the host you're connecting to, and all of these files, right? So, for example, if I'm connected as Json, and I don't think I have a password, let's test it. And it works. There's a check mark, it looks good. I'm actually not too familiar with this because I use the command line more, but you can look at it from this tool. So for example, you can see all of these tables that are there. and what is inside. Like here's the migration table. Oh, actually this is not I think I've set this up wrong. Yeah, sorry. This is not the database I want. Let me modify it. It's connected actually to the wrong database. The database we created is called my database, right? So my database. So that's there we go. Let me try to delete this. Okay. So my database has two tables, job and user. Okay, that makes sense now, because I was looking at it and it was not making sense to me. Okay, so we have a job table and a user table, right? And no migration table because we haven't ran any migration yet. But basically this just says, if we look at what the job item is it just says create the table jobs, and it should have an ID. That's a UUID type, and you can see like it says UUID here. That can't be null, so it can't be empty. And by default, if you leave it empty, it'll generate one for you. And we should have things like a timestamp that says created at, and we'll have this timestamp with at least an entry, so not null again. And then the default behavior is to call this function, and this function just says generate the time now. And here's the updated at. So basically we're tracking like when was the last time this was updated and when was it created. We have an email. So you notice this lists it in a different order, but oh no, because I'm looking at job. So a job has a name, and it's a bunch of characters that can't be empty. So you can't, have no name for a job. And you have to have an author ID of who created this job. And so there's a UUID. This author ID points to which user creates it, and it points to this ID here. Do you know what a UUID is? Kai? Hey, are you there? Okay. Do you know what a UUID is? So quick Google. Google for things you don't know, right? Universal Unique Identifier. That's just a 128-bit number that's generated and tries to be unique. Most of the time it's pretty unique. Almost all the time it's pretty unique. So yeah, for practically purposes, it's unique. Just a unique long number. And then it says this is the primary key. Basically, primary key in a relational database like MySQL just says this key should be indexed. Indexed means sort of kept around for easy retrieval. So we'll refer to this. We'll refer to the different rows in this table by that index. This just says up, and you'll see like how it says up and the down, right? Up just says, okay, what do you do when you want to create a job? And down just says, what do you do when you don't want to have a job anymore? So I don't want to get in too detailed. We can talk about this later. We'll follow the README. So we've done this create database. We've done the yarn watch. That command is running here, and it's open on localhost. Let's look at localhost. Great, it's working. It says cannot get /. So here you can actually play around. There's something called the playground being enabled here, called GraphQL playground. So if you go to localhost/GraphQL, you can play around with the API. So the playground is a developer tool, meaning you in a production environment, you won't actually be able to access this part. So unless you enable it, of course. But the playground looks like this. It comes with GraphQL. You can click on the docs and you can see what kind of things you can run. So for example, I'll create a plus sign and create a new query here. And some of these documents say, maybe I have to register myself. What does that entail, right? It's a mutation, so I don't want to get in too detailed about that, but you type mutation and you say, okay, in this mutation, I want to do a registration. I want to register myself against the server, and I'll have data that's a register input. And what is a register input? I need first name, last name, email, and password. So that's what's going on under the hood. First name J, last name S, email js@example.com, and password is, I believe you shouldn't know about it, but I will let you know. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's the call argument there, and the response, meaning what kind of data it'll provide back to you. It'll provide a user, which is this object here, and a token. The thing that you want to care about is the token, because we'll use that to log in. So that's the string. And if we run this, we should get something. Here's the token. Go ahead and copy and paste this token. And we will be able to do interesting things to it. So create a new tab, and in that token, we can use that token to send authenticated requests. So in the headers, let me first post the token here. Whoops. So in my other headers, you can see there's an authentication part. So if we paste the authentication part here and say, okay, well, instead of this token, I'm going to replace that with this token. I'm just removing the quotation marks. We'll paste it here, and we'll look at the documentation, and we can say, okay, let me look at the myself, tell me about myself. So we can query and say, I want to have me, and return my ID and first name, last name, email, and create it at. Okay. So with this token here, I can call this authenticator route. So it says my ID is this, first name is J, last name S. I just registered here, and that was the timestamp, right? Interestingly, if we go back to look into the database, right? We're in my database. We can look at whether that user was created. So we're going to select everything from the user table. And you can see there's the ID column, created at, updated at, email, password, first name, last name. So that password is, of course, not plain text, so it's a little more secure. The email is here, first and last name. This is a new entry that we just made. Isn't that cool, Kai? Mm-hmm. So that's just talking to the backend. Let's fire up the front end. I'll make a new tab. Go to the front end part and type yarn start. And so if we want to know what that is doing, it is looking at the web part and it's looking at this package.json and it's saying, okay, what is start? Start is basically compile using React scripts and running the start. So it'll take about 15 seconds. Any questions so far? Ooh. Well, almost there. Lastly, we'll just... Okay. 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 A database is essentially a file cabinet, right? So historically, when you, let's say, sign up for membership in a union, right? You have to fill out a form, and that form will be stored inside some file cabinet, right? So you can just think of a database as a file cabinet. So there's a file cabinet and there's different tables. In a table inside a file cabinet can be thought of as like different shelves, is it called? Drawers. Different drawers, right? So let's say we have a table for all of the people that signed up. And I call this drawer the user drawer, right? So if we want to look at all of the users that signed up for membership, we look at this drawer, we open it up, and we start looking through all of the files, the folders, and each folder is a different person. And so the person would be, of course, they can have similar names or in fact duplicate names. Like I can be John Smith and somebody else can be John Smith, and so we don't want the indexing to be through John Smith. We don't want that. We want to have each folder be uniquely identified by having a UUID, and that's where the UUID comes in. So UUID makes sure that you have a unique identifiable folder. And then we can query things like, okay, give me, and the database you can think of as like your secretary. You tell the database through some sort of command, like that looks very databasey, right? It'll look, and all those commands depends on the database you're using. For example, the database we're using is called Postgres. So Postgres takes a certain, has certain features. We won't delve too much into that, but it just says, for example, here I'm looking at, create a table, which is essentially, create a drawer called the user drawer, and have the unique identifiers as ID, have the email passwords as like different fields on this form. And so you can think of like in that folder, there's like a in that form, it says like, oh, what's the ID, or what's the email, what's the password. Does that make sense? So that's what registration did. We did this, in hindsight, I probably shouldn't have done this part. It's diving too deep too quickly. But I just wanted to show you there was this is what it looks like under the hood. And now if we go to, all the pretty interfaces, all this pretty interface is doing is it's doing that part under the hood. So that's okay. It depends. Well, the syntaxes you pretty much have to look up anyways. It's like, in chemistry, right? In chemistry, you might memorize some chemical compounds, the popular ones, but there's no way like you know everything at the top of your head. Like if I asked you, what a certain compound was, you'd have to look it up just to be sure, right? Or if I asked you like, hey, what's the effect of A compound plus B compound, and what is the net result, like energy loss or an energy gain after this reaction, right? You'd look at all that like in some sort of manual, right? So same with like database syntaxes. You might remember the couple common ones, but usually you don't. You look them up. Same with like programming. All programming is, it's like basically just Googling around for what you're trying to do and figuring out, once you get to a point where you memorized a lot of these, you do less and less searching. Okay. Absolutely. Yeah. Yeah. Understanding like the principles that, there's a database somewhere and it doesn't matter what it is. It doesn't matter what the syntax is. You understand the abstraction and you build analogies for yourself and you can understand these things. So here we have the web login page here. Password 1234567 Log in and boom, here we are. So that's it. This website is totally very simple, and this is the whole thing. Yep. Like the database is, the whole point of having a database is for that persistence so that you don't lose it. Error, no internet connection. You don't need an internet. Okay. Well, I think maybe for the next session, I should watch your screen and watch you do it, and then walk you through it. Yeah. Let's use the last 10 minutes or so and wrap up this one. So after I've logged in, I have this nice pretty web page, right? And it's a job posting page, right? And so new job, ha ha ha, right? I'll create a job, and I haven't worked on hooking it up with the other things, but if you hit refresh, you see the job here, right? And you can update. If you want to look at the table, so we'll select everything from the job table, and we can see the job name is called new job, ha ha ha, right? We can modify this. Boiled pasta today. Ride bicycle today. Tomorrow. So if we refresh the page, I haven't hooked it up yet, but if we look at it, we can say, okay, here are 2 jobs, and they should persist even if I log out and log back in. Right? They're still here. And because the database has all of these entries here. That's it. Any questions? Okay. Well then, I think we can wrap up the episode for now, or let's end it with a couple of Q&A questions. Okay. Maybe you have to register a new user. We can look at that. Any conceptual questions? We can look at that in a separate episode. Mm. Well, this is you sound overwhelmed, and I can totally understand that. I mean, I think I was in my first internship at BlackBerry when I was looking at like a project that was built on Ruby and Rails. Basically, it was a web project, and I felt overwhelmed. And by that point, I had taken up to 3rd year. But of course, if you take the thing about school is like I took CS, right? And in CS, it's like you got taught a lot of things across the board. So it's not just web development focused, but I think, the prerequisite, if you were to take this course, would be you need to have an understanding of, programming. You need fluency in at least one language. And then for this one in particular, ideally you have experience using JavaScript or TypeScript. But chances are, if you already know JavaScript, you've already done a bit of web development yourself. So it does take a bit of learning. So probably 3rd year CS would be a good point, because the intern that I am mentoring is a 3rd year CS undergrad, and he was able to pick this up in about 2 weeks, 1 or 2 weeks. So it does take a lot of like reading and understanding. Mm. Probably understand how to model everyday objects in code, right? Like what is a lock and what is a uh, let me give you an example, right? Like suppose so let's do Python, right? Python is very popular. So I might have some level you might need to understand is like we have a lock. Let me just let's say bike lock, right? Here's a bike lock object, and be able to write code like this. A bike lock can takes a key and can lock and unlock, right? And the user and someone can check whether the lock is currently locked or not, right? Something like that. And so be able to be at a level to say, well, let me create a lock object in Python, right? And so what that might look like is, I have a state that says self dot is locked. Initially is like false, and a function that says lock bike, right? And this basically set self dot is locked sets it to true, right? And then maybe another function that says unlock bike, false, right? And that's it. So in this, if you were to run some code and you have to be comfortable enough to say, let me fire up my interpreter, create this paste this thing in there and make a lock to say bike lock equals bike lock, right? And lock bike lock is locked, is not locked right now, but let's lock it. Well, hang on. I did a bad thing. Yeah, because these are object-oriented syntaxes, so you need to put the self in there. Let me paste this again. Lock is a bike lock. And lock, I want to lock it. And now it... Can you see that? Yeah, now we say, well, is it locked? Okay, now it's locked, right? And that's like a very simple abstraction. So modeling some real world objects into code is like some skill set that you need to have. Like understand the syntax enough that you don't need to think too much about this, right? So just, perhaps we should do this. Perhaps for the next couple episodes, we should, as a complete new programmer, learn basic. I think this project is too high level. You won't be able to pick it up without a lot of... Yeah, I don't think you can pick it up without some basic fundamentals. So just having like proficiency, for example, of modeling everyday objects, like this and being able to code it up is sort of like required. Like for example, a pill bottle. I want to make a pill bottle, and the pill bottle basically says, how many capacity is equal to capacity, right? So we can say add a pill, and we can say like, self dot, to self dot pill capacity is now so for example, pills count is 0, right? So now if we add a pill, what happens is the pills count goes up by 1, all right? And but there's a bug, because you first need to check if it's full, right? If self.capacity, if self.pill count is equal to capacity, then then we say something like full, right? And then we return some value, right? Return 0. 0 was added. Otherwise, we can return, 0. We can return -1. Otherwise, we return maybe the pill count, right? So that's what like add pill would be. So, of course, we can try this out and paste that in there and say P is equal to pill bottle. Of course, it's telling me, okay, you didn't tell me what the capacity is. Let's say 3. I can only have 3 pills. If I add a pill, okay, now I have 1 pill, 2 pill, 3 pill, full, right? So like being able to do that just like is sort of like the first requirement. And then you get into the part where solving common problems like solving tic-tac-toe, like build tic-tac-toe, right? Tic-tac-toe is, what tic-tac-toe is, right? So like it's a game that might look like this. So for the audiences that aren't aware of what tic-tac-toe is, it's basically you saying, okay, this was the box that we had, and the winner here is, of course, all of the X's, right? Maybe O's, maybe here is O. So being able to model tic-tac-toe, we can say like, okay, tic-tac-toe object. And we can say, well, what does tic-tac-toe need to have? It needs to have these, this is like a grid, right? But if you look at this and make it flat, what you actually just have is like a list, right? And that's just a list. So, and the list has like, what is this? 0 or like nine things, right? Nine thing list. So self list equals to and actually here's the real world challenge. How do you make sure all of these are I guess we could just put like empty things, right? There. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, there's 9 things in here. Great. Def So that's what a tic-tac-toe thing is. Now play play a cell, and we need to know whether it's X or I guess we need a symbol, right? We need to know who it is, who's playing, and we need to know the position, right? Where position basically says symbol is either X or O, and position is either is a number from 0 to 9, or no, 0 to 8, right? There we go. So then we do some validation. If symbol is either to X or symbol is equal to O, then we just like verify this, and it has to have a position of greater. Let me check something. 1 greater equal to 2 equal to 3. Oh, okay. So you have inline positioning. 0 greater than equal to 8, right? Valid. Yes. Yeah. Else we say print invalid symbol or position, which is symbol and position here. We return like false. Here we return true. Yes, we'll do that later. We can do that later in a loop, right? So here we can say, okay, if we have this position already, then what do we need to do? Well, we need to mark that position at the position as that symbol, right? Oh, but of course we also have to check whether it's, I'll just use another if statement. If the position is already filled, then of course we shouldn't play it, right? Because you can't play a position somebody's already played. If position is not equal to the empty string, then print this position is already occupied, right? Else we can do that, right? And for debugging, let's just print the whole list to C, right? Which is print the self list, right? And this should do what we wanted to do. And let's try it. Let's play symbol A, which won't work, and 2. Right, that it prints, okay, I don't know what you're doing here. Okay, then it puts it here. Let's do it again. It's already occupied. Cool, it's doing exactly what we wanted to do, right? And what we want to do is also now check for a win condition. I guess term finished is finished. So check if is game finished. So a game is finished, right? What are the conditions to finish this game? otherwise, what else? And no more empty spaces, right? Okay, so here's a cool thing where we can define a helper function. Is filled. All filled. Is cell full, okay? And this just takes it just looks at, if we have any sort of these free spaces, right? And so how do we do that? Basically check if there are any remaining in the list, right? So how do we check that? Right. So basically we'll do a for loop for index in from 0 to 8. Actually, for cell in self.list, if cell is equal to this, then false, right? Otherwise, return true. Okay. So that's that. It basically looks at every cell and says, yeah, that's fine, right? Because this only checks if it's full. Right. What you said is if the first cell is empty, then it's not full. No, well, I mean, you don't, right? The first time you see one, then you realize, okay, I have an empty spot right here. Yeah. 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 Yeah, exactly. Exactly. And lastly, we need to check if there are horizontal verticals, right? So the best way is if we define these all separately, horizontal, right? So we have vertical, and it has diagonal. Just for clarity. Is diagonal spelled correctly? I don't know. I'm not a great speller. So basically, we need three conditions, right? If all positions are the same for vertical, then we're good. So if we have 0, 0, 1 equals this. Let me check something. 1 equals 1, true. 1 equals 1 equals 1, true. 1 equals 1 equals true. Okay, so we can this is pretty cool, right? So this is the first one. Or self.list. Let me just copy and paste this because I don't want to type it so many times. Or there may be, but the goal of this exercise is to first program this. So, right, we're if you're asked to find a more efficient, having a solution is better than having no solution but very optimized. This is a classical issue of premature optimization. You don't want to prematurely optimize your code, right? Let's just get it working first. Actually, we don't even need to return true. Return this is sufficient, right? That's basically it. And for the vertical part, we just need to do the same thing, except it's different values, right? What is the vertical value? Let me work it out here. So here we have 0, 1, 2, 3, 4, 5, 8, 6. So vertical is 0, 3, 6, 1, and this is 2, 4, 7, 5, and no, this is 1, 4, 7. This is 5, 2, 5, 8, right? Perfect. And then lastly, diagonal. What is diagonal? Two, 4, 6, right? Great. So I think that's all we needed. And you know, these functions are nested, so that means all of these functions exist only within the scope of this function. Right? Right. So because these are helpers. So now we just need to return is cells full and or has a horizontal, has horizontal, or has vertical, or has diagonal, right? I think this works. I'm not sure if the syntax needs to include the self here. It may need to, I think so. Well, let's just see. What do you mean they don't? So argument is always inside parentheses in Python. These are indexes. These aren't. Yeah, because self is a special term in Python that just says this is an object and this is a function on that object. So it's just the syntax. Let's check if that works. Oh, okay. Python interpreter thinks this is valid. So what do we do? 2, 5, and 7, right? No, 2, 5, 8. So now if we ask it, check if game is finished, it's true, right? Perfect. And so now you have like tic-tac-toe. You know what the game is finished. It doesn't tell you who won, it just tells you finished, which is okay. You can still modify this. And then, we can put a while loop to say, let's make a game called tic-tac-toe. And while tic-tac-toe is not finished, we wait for provide input symbol. I think it's read. What is the input position and play symbol position. Okay, so let me try. Is it input? Yes, it is. Okay, a equals to input. Okay, cool. So input position and user input equals to input, and we'll split symbol and position from the user's input. Okay, so I think this does it. Right, it didn't run. Oh, this is the problem. Why is this wait, there's a bug. No, it's not. Look, it's empty. The game should not be finished. So there's a bug. I wrote something incorrectly. One way is to have print statements everywhere, right? So instead of return, we say result equals to this, and you print all the result. So for example, print result. Here we go. So let me just these are all in the wrong places. There. Now let's try that. Right? Whoops. Yeah. Here we go. And I will paste this. Perfect. Hey, somehow it works. Let's try position. Let's play X in position 0. No, empty string is not equal. Yeah, let's try this again. So we'll play symbol O in 0. Uh-oh. Because it wants an int, not a string. So play O in position 1. Okay, there we go. Let me get rid of all these print statements. This is particularly... Here, first the result is true unless there's some false. There we go. That's better. Okay, position. Oh, you know what? This is the bug we found, right? Because, yeah. Because, you know, empty. Yeah, I got it. Because we have to make sure the default is... So we have to make sure all of these are true. And it's not an empty. Like, let's say one of these is not equal to empty, right? Understand? Yeah, because it is a by default these has vertical, right? So I'll put another bracket. Yeah, I think this was what you were mentioning. I didn't catch on. There we go. So clear all that. Good, all false. Let's play O and play position 1, O position 2, O position 3, still playing O position 4, position 5, O 0, and we have true. Yeah, so that's that. Yeah, anyway, I gotta end this call, but we have made some progress. So you need to be able to do things like this. yeah, I'll send this to you afterwards. But yeah, I gotta drop off. All right. Yeah. Yeah. All right. See you later.